Vector addition. We have these two vectors that we're going to be adding together. The first one, 18.9 meters per second at 48 degrees south of east. The second vector is going to be 11.0 meters per second at 30 degrees north of west. Now, if you notice this little arrow above the vector for velocity, that little arrow, that means that this vector has a direction as opposed to some other measurement like mass that doesn't have a direction, so it wouldn't have an arrow. But since velocity does have a direction, we put a little arrow above it. The six steps we're going to be following. The first step is going to be drawing the vectors. We have our 18.9 meters per second at 48 degrees south of east, and then our 11.0 meters per second at 30 degrees west of north. The next step is to break each one into components. And we're going to have a component that is horizontal and a vertical component for each one of these. For the first one, we're going to have a component to the east and a component that is south. And that should make sense with the directions here. South of east, that means a south component and an east component. And then the second vector is going to have a northern component and a western component. Then we're going to make our chart. We're going to split each vector into x and y directions. So we got our x row here, or y row here, and then each vector is in its column. And then we're going to add those together later, and we're going to get our resultant vector. That's what that r stands for, is resultant. All right, so the first vector is going to have, for the x direction, it's adjacent, so it's going to be cosine of 48 degrees. So 18.9, which is the hypotenuse, cosine of 48 degrees, that's going to be equal to 12.65. If the x direction is cosine, the y direction is automatically sine. You can see that with the diagram too. It's going to be opposite, so we're going to use 18.9 sine of 48 degrees. Now it's south, which means it needs to have a negative. So we punch that in, we get negative 14.05. For the second vector, it's going to be to the north and to the west. Now the x component is to the west, and that is actually opposite the 30 degrees. So we're going to say it's sine of 30 degrees times 11 meters per second. So 11 meters per second, sine of 30 degrees. And it's negative because west is the negative direction. Punch that in our calculator, we get negative 5.5. Next we have the other component, and since the x direction is going to be south, then the y direction is going to be if the x direction is going to be sine, then the y direction is going to be cosine. And punch that in our calculator, we get 9.53 for that. All right, next step. Third step is going to be adding each direction. We take the 12.65 and the negative 5.5, we add that together, we get 7.15. And then we take the negative 14.05 and the 9.53, we add those together, we get negative 4.52. The next step, into step 4, is going to be drawing our new vector. All right, we're going to get rid of those, and we're going to draw our new vector. Our vector is going to have 7.15 for the x component, and that is going to be to the east because it's positive. And then for the y component, it's negative 4.52, so it's going to be south. Now that negative is going to mess up our math, and since we already know that it's south, we already have the arrow pointed there, we're going to go ahead and just get rid of that negative and make it 4.52. And then we have our resultant vector here with the hypotenuse and the angle. The next step is to use a Pythagorean theorem to find the magnitude. So this little bar right here, we usually call that absolute value, but really what absolute value means, if you have a positive number, you keep it positive. You have a negative number, you make it positive. And the reason for that is because you drop the direction. In physics, the negative implies a direction. So the absolute value just means I want the magnitude. I want to know how much, not what direction. So you drop the direction. So the square root of the 7.15 squared plus 4.52 squared, and we get 8.46 meters per second. The angle, the next step, the last step, inverse tangent in order to find the direction. So we take the inverse tangent of opposite over adjacent. So 4.52 divided by 7.15, inverse tangent of that is going to be 32.3 degrees. Now this is where having that negative in for the 4.52 would have messed us up, because if we didn't square the negative with the number, then we would get a wrong answer. And usually our calculators don't include the negative with it unless we put it in parentheses. So we kind of just drop the negative so we don't mess up our numbers and our measurements. All right, so our final answer is the resultant velocity is going to be equal to 8.46 meters per second at 32.3 degrees, and it's south of east. You can see the vector is south of the east direction, so it's south of east. The next one, we have two displacements. The first one is 2.4 meters at 80 degrees north of east. The second one is 1.7 meters at 20 degrees north of east. So we're going to draw our two vectors. Alright, then we're going to break those into components. We're going to have an x component and a y component for the first one, an x component and a y component for the second one. We're going to enclose these 80 degrees and 20 degrees, make our right triangle so it encloses those angles. Now technically you could go up, you can go north and then east and enclose that as your right triangle. Technically you'd be correct and you'd actually get the right answer as long as you follow the steps, but we'd have to figure out that angle. So since it doesn't really matter, I'm going to go ahead and just enclose the 80-degree angle. Alright, so breaking these into components, we've got an x component and y component for each one of these. The x component for the first vector, the x component is going to be 2.4 cosine of 80 degrees, and you can see that's adjacent to it. And that's going to be equal to 0.42. If the x component is cosine, y component is automatically going to be sine. 2.4 sine of 80 degrees, and we punch that in our calculator to get 2.36. For the second vector, the x component is adjacent, so it's going to be cosine. 1.7 cosine of 20 degrees, that gives us 1.6. And then our y direction is going to be sine, because the x direction was cosine, and because it was opposite the 20 degrees. And we get an answer of 0.58. Next, we're going to add each direction. 0.42 plus 1.60 is going to be 2.02. 2.36 plus 0.58, that gives us 2.94. Next step is to draw the new vector, so we get rid of those up there. We go ahead and put our x component as 2.02. Our y component is going to be 2.94. Then we draw our hypotenuse with the angle that we're going to be measuring. Next step is to take the Pythagorean Theorem in order to find the magnitude. So again, we have the absolute value, which means the magnitude is going to be square root of 2.02 squared plus 2.94 squared. We get an answer of 3.57. That's going to be the magnitude. The direction is going to be inverse tangent of 2.94 over 2.02. And that gives us an angle of 55.5 degrees. So our total displacement is going to be 3.57 meters at 55.5 degrees north of east. Now, just to kind of reiterate this and get into what the purpose is for adding vectors. The previous slide we had two vectors that added up. We had one vector up in one direction, then another vector that got us to the same location. So essentially we're taking these two vectors up here and we're simplifying it into just one vector. So this whole process is just taking two vectors, or even more vectors if we wanted to, and then simplifying it so that we only have one vector to describe all of them and get the same thing. The next one, we have velocity vectors because they're measured in meters per second, so 3.0 meters per second at 30 degrees south of west, and then 4.6 meters per second at 45 degrees north of west. First thing is to draw the vectors. We've got our first vector and our second vector. The next step is to draw each component. We're going to an x component, a y component, x component, y component, and then we draw our chart. Our first velocity, velocity 1, the x component is going to be adjacent, so it's cosine. And it's also in the negative direction because it's to the west, and you can see that right here. South of west, that means west is going to be a negative x component, and south means a negative y component. So negative 3 cosine of 30, that gives us negative 2.06. And then we do the y component, which is negative 3 times sine of 30, and that's going to be negative 1.50. For the second vector, we have an x component that's also negative, but the y component is positive. You can see x component west is a negative x, and then north is a positive y. So for the x component, it's cosine, negative 4.6 cosine of 45 degrees. That's going to give us negative 3.25. And then the sine component is going to be 3.25. Next step is to add up each direction, and you get negative 5.85 and 1.75. Next, we're going to draw our new vector. Our new vector is going to have, in the x direction, it's going to be negative 5.85. Now we're going to go ahead and get rid of that direction of negative because we already have the direction here, and that negative is really just going to mess up our math later. So we're just going to go ahead and drop it, and we'll still get the same answer, the correct answer at the end. The y component is 1.75, and then we have our hypotenuse with the angle that we're going to find. Next step is to use the Pythagorean Theorem in order to determine the magnitude of the vector. It's going to be 1.75 squared plus 5.85 squared. Take the square root of that and you get 6.11 meters per second. The direction is going to be inverse tangent of 1.75 divided by 5.85, and we get 16.7 degrees. So the total velocity is going to be 6.11 meters per second at 16.7 degrees north of west. The next one, we're going to have two vectors, and if you notice, we have an N here. If you remember, the N, capital N, stands for newtons, which is a force. So we have two force vectors we're going to be adding together. First, we need to draw the two force vectors. Next, we need to break each one into components. We're going to go, on this one, we're going to go south and then west. And this one, we're going to go east and then north in order to make our components. Then we draw our chart, x and y directions for each force. And since these are vectors also, we have the little arrow above it to designate that it has a direction. X component for the first one is opposite. The x component is opposite. It's going to be in the west direction. So it's going to be sine, negative 9.2 sine of 68 degrees, and we get negative 8.53. Since the x component is sine, the y component is adjacent, it's cosine, so we have a negative 9.2 cosine of 68 degrees. Again, it's going to be negative because it's pointed downward or south, so we get negative 3.45. For the second vector, the x component is adjacent, so it's going to be cosine, so 12.8 cosine of 25, we get 11.6. The y component is going to be sine, and we get 5.41. Next step is to add up each direction. We get a total of 3.07 in the x direction, 1.96 in the y direction. Then we're going to draw our new vector. The new vector is going to have 3.07 as the x component. The y component is going to be positive 1.96. And then we go ahead and draw our vector there with its direction and angle. Using the Pythagorean Theorem, we figure out the net force, the total force. The resultant force is going to be 3.64 newtons. And then the angle is going to be inverse tangent of 1.96 over 3.07. And we get 32.6. So the total force is going to be equal to 3.64 newtons at an angle of 32.6 degrees north of east.